The morning fog still clung to the proving grounds at Kummersdorf, south of Berlin, as Hauptmann Klaus Weber stepped out of the staff car. It was early March 1943, and the captured American tank sitting on the test pad looked almost absurdly clean, its olive-drab paint barely scratched, the white star on its turret side still crisp. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Weber had spent the last 5 years evaluating enemy armour. French Somuas, British Matildas, Soviet 34s. He'd crawled through dozens of knocked-out tanks, measured armour thickness, examined transmission housings, compiled reports that gathered dust in ordnance offices. But this one felt different. This M4 medium tank, captured from the American 1st Armoured Division in Tunisia just weeks earlier, represented something the Wehrmacht hadn't faced before. American industrial might translate it into steel. His team of engineers stood waiting, clipboards ready, measuring tools laid out with Prussian precision. Oberingenieur Friedrich Hartmann, who'd designed components for the Panzer IV before the war, gestured toward the tank with barely concealed skepticism. "It looks like a tractor," Hartmann said, his breath visible in the cold air. "The Americans send a tractor to fight the Panther." Weber didn't respond immediately. He'd read the intelligence briefs. The Americans had no tank tradition, no armoured warfare doctrine worth mentioning. They'd entered the war with obsolete designs and were now frantically trying to build something, anything, to put into the field. This Sherman was probably rushed into production, corners cut, quality sacrificed for quantity. But something nagged at him as he approached the tank. The hull welds looked clean. The tracks showed even wear. The sponsons where ammunition was stored seemed thoughtfully designed. This didn't look like a rush job. "Let's open her up," Weber said. "If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today." The driver's hatch swung open easily, the hinges well-oiled despite the tank's capture and transport. Weber climbed in, followed by Hartmann. The interior smell hit him first, a mixture of oil and leather and something else, something almost pleasant. Not the acrid stench of overheated metal and burned rubber that permeated German tanks after a few hours of operation. The driver's position surprised him. The seat was adjustable, padded. The instrument panel was laid out logically, gauges grouped by function, clearly labelled. The visibility through the periscope was excellent. The controls, the steering levers, even the floor pedals, felt positioned for comfort rather than just minimum functional spacing. "IV," Hartmann muttered, running his hand along the instrument panel. "Look at this. The Americans put more thought into the driver's comfort than we put into the entire forward compartment." Weber shifted in the seat, testing the positioning. After 5 minutes, he wasn't cramped. After 10, his back didn't ache. In a Panzer IV or a Panther, drivers complained of back pain after an hour. Tank commanders regularly reported that exhausted drivers made mistakes that got crews killed. "Start documenting everything," Weber ordered. "Dimensions, angles, sight lines. I want to know why this works so well." Over the next 3 days, Weber's team methodically disassembled the Sherman's interior. What they found contradicted everything they'd been told about American tank design. The turret basket rotated with the turret, a seemingly obvious feature that German tanks lacked. In a Panzer IV, the crew had to carefully coordinate movement as the turret traversed, stepping over ammunition, avoiding the breech as it swung. In the Sherman, the crew rotated with their workspace. Simple, efficient, obvious in retrospect. The commander's cupola offered visibility that made German designs look primitive. 6 periscopes gave 360-degree vision. The commander could scan the battlefield without exposing himself to enemy fire. German tank commanders, even in the vaunted Panther, had to open hatches or use limited-view episcopes, but it was the gun that revealed the first truly shocking discovery. Lieutenant Hans Müller, a gunnery specialist from the artillery proving grounds at Hillersleben, had been assigned to evaluate the 75mm M3 gun. He'd expected a simple weapon, probably copied from French designs, certainly inferior to German engineering. On the fourth day of testing, Müller called Weber to the turret. "Hauptmann, you need to see this." Weber climbed up, joining Müller at the gunner's position. Müller pointed to a series of components, connected to the gun's elevation mechanism. "This is a gyroscopic stabilization system," Müller said, his voice carrying an edge of disbelief. "The gun maintains its elevation regardless of hull movement." Weber stared at the mechanism. Gyroscopic stabilization was theoretical technology, something engineers discussed at conferences. The Kriegsmarine used primitive stabilization on some anti-aircraft mounts, but it was complex, temperamental, required constant maintenance. "Are you certain?" "I've tested it," Müller replied. "Watch." He activated the system, and the gun's barrel remained perfectly level, even as two technicians rocked the entire tank by pushing on the hull. The 75mm tube stayed locked in position, compensating automatically for movement. "My God," Hartmann breathed. "They can fire accurately while moving." "Not just while moving," Müller corrected. "When they stop, the gun is already on target. No delay for the barrel to settle. They get the first shot off faster than we do." The implication settled over the group like a physical weight. In tank combat, the first shot was often the only shot that mattered. The Germans had built their entire doctrine around superior optics and careful aiming. The Sherman stabilization system bypassed that advantage entirely. "The Americans are giving this technology to ordinary crews," Weber said quietly. "Farm boys and factory workers. They're using engineering to compensate for training deficiencies." "No," Hartmann countered. "They're using engineering intelligently. Even our best-trained crews would benefit from this. We've been so focused on gun penetration and armor thickness, we ignored the question of whether the crew can actually employ the weapon effectively under combat conditions." Weber ordered a complete analysis of the stabilization system. The Westinghouse Company identification plate told them nothing. The design was proprietary, but the engineers could see the elegance of the solution. Hydraulic pressure from the turret traverse system powered the stabilizer. A simple gyroscope detected vertical movement. An electric motor made fine adjustments. It wasn't overcomplicated. It just worked. The testing continued. The suspension proved to be another revelation. The vertical volute spring system, derided in intelligence reports as crude and outdated, actually performed beautifully. Each bogie was independent. If one road wheel was damaged, the others compensated. Replacement took less than an hour with basic tools. "Look at this," said Feldwebel Otto Schmidt, the team's maintenance specialist. He held up a bogie assembly. "Every component is standardized. This exact part fits any M4, regardless of which factory built it. The Americans can cannibalize damaged tanks for parts in the field." Schmidt had spent 2 years keeping Panther tanks operational on the Eastern Front before being recalled for evaluation work. He knew the nightmare of German tank maintenance. Panthers built at different facilities used slightly different components. A drive sprocket from a Daimler-Benz Panther wouldn't fit a MAN Panther. Field repairs required depot-level facilities and specialized parts. "And the tracks," Schmidt continued, his voice taking on an almost reverent tone. "Rubber block tracks that don't destroy roads. They last 6,000 kilometers. Our steel tracks barely make 800 before they need replacement." Weber watched as Schmidt demonstrated how quickly a Sherman track could be repaired. The rubber blocks were held on with simple bolts. A damaged section could be replaced in minutes. German tank tracks used complex pins that required special tools and often had to be heated for installation. "The Americans have thought about logistics," Weber said. "They've designed this tank assuming it will need field repairs, far from any depot, by crews with minimal training." "While we," Hartmann replied bitterly, "designed the Panther, assuming it would have access to factory-level maintenance at all times." The engine examination took place on day 6. Weber expected American automotive engineering, derived from car and truck manufacturing, to be the Sherman's strength. He was still unprepared for what they found. The Continental R975 radial engine sat in the rear compartment, easily accessible through large hatches. 9 cylinders arranged in a radial pattern, just like an aircraft engine. It was loud, yes, and not particularly powerful by German standards at 400 horsepower. But it was reliable. Schmidt ran the engine for 6 hours straight, monitoring temperatures, checking for leaks, listening for unusual sounds. Nothing. The engine ran smoothly, consistently, without drama. Oil pressure remained stable. Coolant temperature stayed within acceptable ranges. There were no mysterious vibrations, no concerning noises. This engine has been captured, transported over 1,000 kilometers, sat, idle for weeks, and it starts on the first attempt, Schmidt reported. I've seen new Panthers that wouldn't do that. The maintenance manual, translated from English, revealed another advantage. The manual was written for soldiers, not engineers. Clear diagrams showed exactly how to service each component. Troubleshooting guides walked mechanics through common problems step by step. The Americans assumed their tank crews wouldn't have advanced technical training. They've made complexity transparent, Hartmann observed, flipping through the manual. Look at this section on the transmission. It tells you exactly what sounds indicate which failure modes. A crew can diagnose problems without special equipment. The transmission itself proved to be another exercise in American pragmatism. 5 forward gears, 1 reverse. Synchronized shifting made operations smooth. The entire unit could be removed from the front of the hull by unbolting just 12 bolts and disconnecting 4 linkages. In a depot, a trained team could swap a transmission in under 3 hours. Contrast that with the Panther, Schmidt said. To remove the transmission, you have to lift out the entire driver's compartment. It takes a day, minimum, with a crane and specialized lifting equipment. Weber made detailed notes. The pattern was becoming clear. Every aspect of the Sherman's design prioritized operational efficiency over theoretical performance. The tank wasn't trying to be the best at any single metric. It was trying to be good enough at everything while remaining easy to operate, maintain, and repair. On day 8, they conducted automotive trials. They drove the Sherman around the Kummersdorf test course, over obstacles, through mud at various speeds. The handling surprised everyone. It's agile, Mueller reported from the driver's seat. Tight turning radius, good visibility. The controls are light enough that I'm not exhausted after an hour of driving. They measured fuel consumption, nearly 5 kilometers per litre on roads, about 2.5 cross-country. The Panther managed barely 1.3 kilometers per litre under ideal conditions. The Sherman's operational range was nearly double that of German medium tanks. Because they use gasoline engines, Hartmann noted. Diesel would be even better, but they've chosen an engine that can use the same fuel as their trucks and aircraft. Logistical efficiency again. The armor testing came next. Here, finally, was something that confirmed German expectations. The Sherman's frontal armor was 51 millimeters at 56 degrees, adequate against most threats in early 1943, but hardly impressive by German standards. They fired various German anti-tank weapons at the captured hull. The 50mm Pak 38 penetrated easily at 500 meters. The 7.5cm Pak 40 punched through at over 1,000 meters. The Sherman's armor wasn't going to stop any German gun currently in service. But look at this, said Hauptmann Dieter Vogel, the ballistics specialist. He pointed to the penetration pattern. The armor doesn't spall badly when penetrated. The face-hardened plate tends to crack cleanly rather than fragmenting. And see here, they've sloped it well. The effective thickness is better than the nominal thickness suggests. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. Vogel had Weber climb into the tank while they fired into a test plate positioned where the hull would be. Even though the plate was breached, the interior remained surprisingly clean, minimal spalling. The crew would likely survive a penetrating hit that would kill everyone in a poorly designed tank. And the ammunition storage? Vogel continued. They've put it below the turret basket, in the hull floor, surrounded by water jackets. If a fire starts, the water delays cooking off the ammunition long enough for the crew to escape. This was wet stowage, a feature introduced after earlier Shermans had proven dangerously prone to brewing up when hit. The Americans had identified a problem and engineered a solution rapidly. German tanks still stored ammunition wherever it fit, reliability and crew survival be damned. The crew ergonomics impressed everyone who actually sat in the tank. The loader's position provided easy access to stored ammunition. The gunner had a comfortable seat and clear sight picture. The commander had that excellent all-around vision cupola and a separate machine gun he could operate without interfering with the main gun. 5 men working in a coordinated space, Hartmann summarized. Compare that to our designs where crew members constantly interfere with each other's work. By day 10, Weber had compiled enough data for a preliminary report. He sat in his temporary office at Kummersdorf, staring at his notes, trying to formulate conclusions that wouldn't sound defeatist. The Sherman wasn't a better tank than the Panther in any single category except reliability. Its armor was thinner, its gun less powerful, its top speed lower. But as a complete weapons system, designed for total war, it was arguably superior. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Americans had made conscious trade-offs. They'd sacrificed maximum performance for operational availability. They'd accepted good enough instead of pursuing perfection. Most importantly, they designed the tank not for showing off at demonstrations, but for fighting prolonged campaigns, thousands of kilometers from American factories. Weber understood the implication. Germany was still producing tanks as if they were bespoke racing cars, each one a testament to German engineering excellence. America was producing tanks as if they were consumer appliances, designed for mass production, easy operation, and field serviceability. The question wasn't which approach built a better tank on paper. The question was, which approach would win a multi-year war of attrition? He began writing, Evaluation Report, American M4 Medium Tank. The captured M4 represents a fundamentally different design philosophy from German armored vehicles. Rather than maximizing individual performance metrics, American engineers have optimized for operational efficiency and industrial producibility. Notable features include 1. Crew ergonomics significantly superior to comparable German tanks. Spacious fighting compartment, good visibility for all crew positions, thoughtful control layouts. Tank commanders can maintain situational awareness without compromising protection. This technology allows engagement of targets while moving and significantly reduces time required to aim after stopping. No German tank currently possesses this capability. 3. Maintenance-focused design. Standardized parts, easily accessible components, comprehensive technical documentation designed for minimally trained mechanics. Field repairs can be conducted with basic tools. 4. Automotive reliability exceptional. Powertrain demonstrates consistent performance under varied conditions. Operational range approximately double that of Panther medium tank. Weber paused. He needed to address the elephant in the room. Why this tank, inferior on paper to German designs, might actually be a more dangerous opponent than anyone in the Wehrmacht wanted to admit. He continued, Strategic assessment. The M4's armor and main gun are adequate but unimpressive by current standards. However, these apparent deficiencies miss the larger picture. The Sherman is designed to be produced in vast numbers, maintained by ordinary soldiers and kept operational under field conditions, where German tanks frequently break down. American intelligence suggests monthly production exceeding 2,000 units. If accurate, American tank production will soon exceed total German armored vehicle production across all categories. More concerning, the design is clearly intended to be upgraded. The large turret ring and roomy fighting compartment can accommodate heavier guns. The automotive components have sufficient power reserves for increased weight. The Americans are not building a final design. They are building a platform. Weber looked at what he'd written. It read like defeatism. But it was the truth, and the Wehrmacht needed truth more than comforting lies. The testing continued into the second week. They examined the electrical system, the radio equipment, the periscopes and vision devices. Each element revealed the same pattern. American engineers had chosen solutions that prioritized reliability and ease of use over maximum theoretical performance. The radio, for instance, was a robust unit with simple controls. The frequency range wasn't as broad as German sets, and the maximum range was shorter, but it worked consistently, didn't require constant adjustment, and could be operated by anyone who could follow the clearly labeled controls. German radio operators needed extensive training. American radio operators needed to be able to read English. On day 12, Oberst Heinrich Steiner arrived from Berlin. Steiner was a career armor officer who'd commanded Panthers in Russia and had direct access to General Guderian's staff. His presence meant the evaluation was being taken seriously at the highest levels. Weber briefed Steiner on the findings, walking him through the disassembled tank, demonstrating the stabilization system, explaining the maintenance philosophy. Steiner listened in silence. When Weber finished, the colonel stood staring at the Sherman for a long moment. "You're telling me," Steiner said slowly, "that the Americans have built a tank that's easier to switch operate, easier to maintain, and more reliable than our Panthers, and they're producing it in numbers that will make our production look like a joke, Herr Oberst. But our tanks have better armor and better guns. Significantly better, yes. Which matters more in combat?" Weber had been dreading this question. "It depends, Herr Oberst. In a direct engagement at medium range, one Panther will defeat multiple Shermans. But warfare is not a series of isolated duels. The Sherman that breaks down less frequently, requires less maintenance time, can be repaired in the field, and arrives at the battle because it didn't run out of fuel along the way. That Sherman is the more dangerous enemy." Steiner walked around the tank slowly. He climbed into the driver's position, tested the controls, examined the instrument panel. Then he moved to the commander's cupola, looking through the periscopes, checking the sight lines. "The crews who operate this tank won't be exhausted from fighting the vehicle itself," Steiner observed. "They'll be able to focus on fighting the enemy." "Exactly, Herr Oberst. And the Americans will have parts to repair damaged tanks while we'll be cannibalizing 3 broken Panthers to keep one operational." "Based on current supply situations, yes." Steiner climbed down from the tank. "What you're describing isn't just a different tank, Hauptmann. It's a different way of thinking about warfare. We're still thinking like a small professional army needs to think, where each vehicle is precious and must be individually superior. They're thinking like a continental industrial power, where logistics and sustainability matter more than individual superiority." "The assessment is accurate, Herr Oberst. And we can't change our production methods to match theirs, can we? Our entire industrial base is fragmented among dozens of manufacturers, each jealous of their designs. We don't have the centralized production capacity or the Timutian standardization to replicate what the Americans are doing." Weber said nothing. The question was rhetorical. Everyone knew German war production was hobbled by political infighting and industrial inefficiency. "Write your report," Steiner ordered. "Tell the truth. If High Command wants to ignore it, that's their decision. But at least the information will be on record." After Steiner departed, the testing moved to combat simulations. They organized mock battles, pitting the Sherman against various German tanks in theoretical engagements. The results were illuminating. In a static, prepared position at long range, German tanks dominated. The Panther's 7.5 cm KWK-42 could engage the Sherman at ranges where the American gun was ineffective. Under these ideal conditions, German armor superiority was undeniable, but combat was rarely ideal. They simulated meeting engagements where both tanks stumbled upon each other suddenly. The Sherman's stabilization system gave it a crucial advantage. It could fire accurately within 3 seconds of stopping. The Panther needed 6 to 8 seconds for its gun to settle and the gunner to aim properly. In those few seconds, the Sherman had often fired twice. They simulated extended operations, where tanks had to move 50 kilometers, engage in combat, then move another 50 kilometers. The Sherman completed the exercise without mechanical issues. The test Panther, a relatively new vehicle, developed a fuel pump problem and had to be recovered. They simulated crew efficiency under fatigue conditions. After 6 hours of continuous operation, the Sherman crew remained relatively fresh. The Panther crew was exhausted from wrestling with heavier controls, cramped positions, and poor visibility. "This is what's actually going to happen in Normandy," Hartmann said, watching the exhausted Panther crew climb out of their vehicle. "The fighting won't be these clean, long-range engagements our doctrine assumes. It'll be confused. Close-range battles in hedgerows and villages. The tank that can fire first after movement, that has a crew alert enough to spot threats, that actually makes it to the battlefield instead of breaking down. That tank wins." Mueller had been documenting the combat simulations. "The stabilization system is decisive in meeting engagements," he reported. "Even when we tell the Panther crew exactly where the Sherman will appear, the American tank gets off the first shot in 7 out of 10 trials. And the first shot is often the only shot that matters," Weber noted. By week 3, the team had examined every aspect of the Sherman. They'd measured every dimension, photographed every component, documented every system. The captured tank was beginning to show wear from the intensive testing, but it was still operational, still reliable. The final report ran to over 200 pages. Weber tried to be objective, noting both strengths and weaknesses, but the conclusion was unavoidable. The Sherman represented a more mature understanding of industrial warfare than anything Germany was producing. The summary section was the hardest to write. "The M4 Sherman is not a superior tank to the Panther in direct comparison of primary combat characteristics. However, this comparison is misleading. The Sherman was not designed to be superior in isolated metrics. It was designed to be produced in massive quantities, operated by minimally trained crews, maintained under field conditions, and kept operational through extended campaigns. In this, it succeeds completely. More concerning, the Americans are still early in their learning curve. This tank was designed in 1941 with no combat experience. They have now been fighting in North Africa for months and will incorporate those lessons into future designs. The large turret ring suggests they are already planning to mount heavier guns. The robust automotive components can handle increased weight. We should expect successive generations of Sherman variants, each addressing weaknesses identified in combat. The American industrial base can implement changes across their production line within months. Our fragmented production system requires years to make similar changes. Recommendation: rather than dismissing the Sherman as inferior, Wehrmacht forces should prepare for facing large numbers of these tanks, operated by increasingly experienced crews, supported by excellent logistics, and continuously improved based on combat experience. The war will not be won by which side has the theoretically superior individual tank. It will be won by which side can keep the most tanks operational in the field. By this measure, the Sherman is a more dangerous weapon than its armor and gun specifications suggest. Weber submitted the report through channels. He heard nothing back for 3 weeks. Then word came that he was being reassigned to a technical liaison position with a panzer regiment. The unspoken message was clear. His analysis had been noted and filed away, But nobody in Berlin wanted to hear that American tanks might be strategically superior despite being tactically inferior. By summer 1943, more Shermans were being captured. In Sicily, entire Italian units equipped with Allied vehicles surrendered intact. The Germans found M4 tanks with various modifications, different engine types, improved ammunition storage, heavier armor on some variants. The Americans were iterating their design constantly, not revolutionary changes, but incremental improvements, better tracks, uprated engines, modified turrets. Each change addressed specific combat lessons, the industrial machine learning in real time. And the numbers kept growing. Intelligence estimates suggested American tank production was approaching 3,000 per month by late 1943. Germany's total armoured vehicle production, including all tank destroyers, self-propelled guns, and assault guns across all models, barely reached 1,000 per month. Weber's prediction was coming true. The question wasn't whether individual Shermans could defeat individual German tanks. The question was whether German forces could sustain combat against an enemy who could replace losses faster than they could inflict them. By autumn, reports from Italy confirmed the pattern. American tank units took heavy losses in frontal engagements, but never seemed to run out of tanks. Knocked-out Shermans were recovered, repaired, and back in action within days. Damaged German tanks often sat immobilized for weeks, waiting for replacement parts that never arrived. The Americans were even using captured Shermans for recovery vehicles. German units that managed to capture intact Shermans were delighted. The tanks were reliable, easy to maintain, and could tow broken-down Panthers back to repair depots. Tiger units in particular loved captured Shermans because they were the only recovery vehicles robust enough to tow a Tiger. There was a bitter irony in German tank crews preferring captured American tanks to their own authorized recovery vehicles. The Berger Panther recovery vehicle, based on the Panther chassis, was theoretically superior, but broke down as frequently as the tanks it was supposed to recover. Shermans just worked. In late 1943, Weber received a copy of an interrogation report. An American tank crew, captured in Italy, had been questioned about their training and doctrine. The transcript was revealing. The Sherman crews received approximately 12 weeks of training before deployment. Basic driving, gunnery, maintenance, and tactics. Nothing elaborate. The Americans assumed the tank itself would be easy enough to operate that extensive training wasn't necessary. German Panther crews received over 20 weeks of training and still frequently made operational errors because the tank was so complex. The American doctrine was equally straightforward. Sherman tanks were infantry support vehicles first, tank destroyers second. They expected to fight primarily against anti-tank guns, infantry positions, and fortifications. Tank versus tank combat was anticipated but not the primary mission. When Shermans did encounter German armor, American doctrine emphasized combined arms. Call for air support, call for artillery, use tank destroyers, maneuver to flanks, don't engage in frontal duels with heavier German tanks. They've accepted their limitations and built doctrine around them, Hartmann observed when Weber shared the interrogation transcript. While we insist every tank must be capable of defeating any enemy tank in single combat, because we don't have enough tanks for specialized roles, Weber replied. The Americans can afford to have Shermans for infantry support and Montan tank destroyers for anti-tank work. We need each Panther to do everything. Which means Panthers do nothing well. They're too valuable to risk in infantry support roles, not mobile enough for exploitation, and break down too frequently to be reliable tank killers. The conversation was treasonous by Nazi Party standards, but by late 1943, among combat veterans and technical specialists, such conversations were common. The gap between propaganda and reality had grown too wide to ignore. In January 1944, Weber received new orders. He was to evaluate recently captured examples of the M4A38, nicknamed the Easy 8 by American troops. This latest Sherman variant incorporated horizontal volute spring suspension, wider tracks, and a new 76mm gun with improved penetration. The Americans were upgrading their design, not replacing it, upgrading it. The basic Sherman platform remained, proving its adaptability. But now it had better mobility and better firepower. The new 76mm gun was still inferior to the Panther's 7.5 centimeter KWK-42 at long range. But at ranges under 800 meters, in the close terrain of Western Europe, the difference was less significant, and the Sherman still had that stabilization system, still had better ergonomics, still had superior reliability. Weber's evaluation of the EZ-8 confirmed his earlier conclusions. The Americans had identified weak points in their design and addressed them systematically. The wider tracks reduced ground pressure, improving mobility in soft terrain. The new suspension rode smoother, reducing crew fatigue. The heavier gun gave crews more confidence engaging German armor. Most importantly, all these improvements were compatible with existing Sherman variants. Parts were standardized. Older Shermans could be upgraded in field workshops. The entire Sherman fleet was becoming more capable without requiring completely new production lines. This is what we should have done with the Panzer IV, Hartmann said, examining the EZ-8's suspension. Continuous incremental improvement of a proven design. Instead, we abandoned it for the Panther, which turned out to be a maintenance nightmare. The Panzer IV was politically unacceptable, Weber replied. It wasn't advanced enough, not impressive enough. The party wanted wonder weapons, not merely adequate weapons. And now we have wonder weapons that don't work half the time, while the Americans have adequate weapons that always work. By early 1944, the pattern was undeniable. Every captured Sherman variant showed the same characteristics: reliability, ease of maintenance, crew-focused design. The Americans weren't trying to build the best tank, they were building the tank that would win the war. Reports from the Eastern Front confirmed that Soviet forces were also receiving Shermans through Lend-Lease. Soviet tank crews, accustomed to the cramped, crude 34, reportedly loved the Shermans. Spacious interiors, good visibility, reliable engines. Some Soviet units were requesting more Shermans instead of Soviet-built tanks. The irony was thick. German propaganda claimed American tanks were inferior death traps, but experienced tankers on both sides, when given a choice, often preferred Shermans to their own authorized vehicles. In May 1944, with the Allied invasion of France imminent, Weber was summoned to a planning conference in Paris. Panzer commanders were being briefed on expected enemy equipment in Normandy. The intelligence estimates predicted hundreds of Sherman tanks would be involved in the initial landings, with thousands more arriving in subsequent weeks. The latest variants with heavier guns and better armor would be present in significant numbers. A young Hauptmann from a newly formed panzer division raised his hand. Herr Oberst, we've been told that one Tiger is worth 5 Shermans. Is this accurate? The briefing officer, an experienced tanker from Russia, paused before, answering carefully. In ideal conditions, open terrain, long range, with a fresh crew, and a fully functional Tiger. Yes, one Tiger can engage 5 Shermans successfully. However, these conditions rarely exist in combat. What conditions should we expect in Normandy? Close terrain, hedgerows limiting sight lines to 100 meters or less, Allied air superiority preventing daylight movement, insufficient fuel for extended operations, limited spare parts, constant mechanical breakdowns. Under these conditions. The officer paused. Under these conditions, the Sherman's reliability and the Americans' ability to rapidly replace losses become decisive factors. The room fell silent. This wasn't the confident briefing the young officers had expected. Our tactical superiority is real, the briefing officer continued, but it's not sufficient to overcome their operational and strategic advantages. They will have more tanks, more fuel, more spare parts, and complete air. Superiority. We must be realistic about what we face. Weber sat in the back of the room, listening to the briefing that echoed his own reports from a year earlier. The truth was finally being spoken openly, but it was too late to matter. The American industrial juggernaut was already in motion, and nothing Germany could do would stop it. After the briefing, Weber stood outside smoking, watching German supply trucks struggle past with gasoline for the panzer divisions. The trucks were a mix of captured French vehicles, obsolete German models, and pressed into service civilian trucks. None of them were standardized. All of them were maintenance nightmares. A few kilometers away, American forces were preparing to land with their standardized trucks, their reliable Shermans, their mountains of spare parts and fuel. Everything designed to work together, everything built to keep working under field conditions. "We lost this war in our factories," Hartmann said, joining Weber. "No matter how bravely our soldiers fight, or how clever our tactics are, we can't overcome the fact that they simply outproduce us with better designed equipment. The Sherman is the proof," Weber agreed. "Not the best tank, but the right tank for total war." The summer heat of 1944 brought more than just the Allied invasion of Normandy. It brought a flood of after-action reports from panzer units engaged against Sherman tanks in the Bocage country of France. Weber, now assigned to a technical analysis section in Paris, read them with grim recognition. Every report confirmed what his testing had predicted 18 months earlier. A report from Panzer-Lehr Division, dated June 15, 1944. Encountered 12 Sherman tanks in close terrain near Tilly-sur-Seulles, destroyed 7 with minimal losses. However, American unit returned to action next morning with 6 replacement tanks. Our damaged Panthers remain inoperable, awaiting parts that have not arrived. Another from the 2nd SS Panzer Division Das Reich, dated July 3rd. Extended combat operations impossible due to fuel shortages and mechanical failures. American tank units maintain continuous pressure despite heavy losses. Enemy appears to have unlimited replacement vehicles and ammunition. The pattern repeated across every sector. German units won tactical engagements but lost the operational campaign because they couldn't sustain combat. The Shermans kept coming, kept fighting, kept being repaired, and returned to action. German tanks sat immobilized, waiting for parts, waiting for fuel, waiting for recovery vehicles that were themselves broken down. Oberleutnant Karl Becker, a Panther commander who'd survived 2 months of Normandy fighting, was brought to Paris for debriefing in August. Weber was assigned to interview him. Becker looked a decade older than his 26 years. His uniform was stained. His hands trembled slightly as he accepted coffee. He'd commanded Panthers since Kursk, was decorated for valor, knew German armor inside and out. "Tell me about fighting the Shermans," Weber prompted. Becker lit a cigarette before responding. "The first thing you notice is there are always more of them. You knock out 3, 5 more appear. You retreat to rearm and refuel. They're still there, waiting. They never stop coming. But individually, your Panther is superior." "On paper, yes. At 800 meters, I can kill a Sherman before it can touch me. But Normandy isn't about 800-meter shots. It's hedgerows, sunken roads, villages. You don't see the enemy until you're 50 meters apart, sometimes less. At that range, his 76mm gun will penetrate my armor, and he gets his shot off first. The stabilization system? That damned stabilizer, yes. They come around a corner, they're already aiming. We come around a corner, we need seconds to settle and aim. In tank combat, Hauptmann, seconds mean everything. I've lost 2 Panthers because American guns were on target before we were." Weber made notes. This matched the simulation results from Kummersdorf. "What about reliability?" Becker laughed bitterly. "My company started the Normandy campaign with 17 Panthers. After 6 weeks, we had 4 operational. The rest broke down. Final drives, mostly. Also transmissions, engines, fuel pumps. The Americans? I watched a Sherman throw a track. The crew had it repaired in 20 minutes. I watched another Sherman take an 88 hit that knocked out the turret. They towed it back, and 2 days later it was fighting again with a new turret. Meanwhile, my Panthers with mechanical failures sit in a field near Caen waiting for parts that will never arrive. Did you capture any Shermans? Becker's expression softened. 3 intact. We used them immediately. Best recovery vehicles we had. Reliable, powerful, easy to operate. My men preferred them to our own Burger Panthers for recovery work. One of my drivers, Unterscharführer Roth, had previously operated a Panther for 2 years. I put him in a captured Sherman for 1 week. He begged me not to transfer him back, said the Sherman was like driving a car compared to wrestling with the Panther. The Americans have made the tank subordinate to the crew, Weber observed. We've made the crew subordinate to the tank. Exactly. In a Panther, I spend half my energy managing the vehicle itself. In a Sherman, the crew can focus on fighting. The Americans built a tank for soldiers. We built a tank for engineers to admire. The interview continued for 3 hours. Becker's observations matched Weber's technical analysis with brutal clarity. The Sherman wasn't winning because it was better in individual capability. It was winning because it was better designed for the totality of mechanized warfare. After Becker left, Hartmann entered Weber's office. He'd been conducting similar interviews with other Panzer veterans from Normandy. I've spoken with 14 Panther commanders this week, Hartmann reported. Every single one tells the same story. We win the first engagement, then we lose the campaign because we can't sustain operations. The Shermans keep fighting. Our Panthers keep breaking. Have you shown these reports to anyone in Berlin? I've tried. The response is always the same. We're told our defeatist attitude is the problem, not our tanks. We're told the Panther is the finest tank in the world and our reports are exaggerated. Weber wasn't surprised. By late 1944, reality had become unacceptable to the Nazi leadership. Admitting that American tank design philosophy was superior would undermine the entire narrative of German technical supremacy. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.